Hi everyone, thank you very much for joining this session, Rolling Out Like a Rock Star. My name is Nicola Corti and I work as Android infrastructure engineer at Spotify in Stockholm, Sweden. You can find me online on Twitter as Cortinico and on GitHub as Cortinico. Make sure you follow me over there and drop me a message if you have questions or you want just to follow up on anything. And if you like running, make sure you follow my playlist Running in Stockholm. You can scan the Spotify code down here in the slide. And so it all starts from here. It starts from music. And I want to start this talk presenting one of the most popular Swedish group out there. And this group is ABBA. It's really, really popular. And by the way, if you happen to be in Stockholm, where our headquarters is, you probably want to know that there's also a ABBA museum. So if you're interested, make sure you stop by. But why I'm telling you this? Because ABBA is the name of our first A/B testing framework. That was actually a pretty smart name. But sadly, ABBA had a couple of problems. It was really hard to scale. It was really complicated to maintain. And the problem with ABBA was that everything was global. It was really hard to pinpoint which team was owning which flag. And it was just not flexible enough for us to follow the growth of our company. So at a certain point, we just decided that ABBA was not enough for us anymore, and we created a new tool. So today, I'm happy to introduce our new experimentation framework called remote configuration. So this talk is going to be about what we built, why we built it in a certain way, and which capabilities we offer to our developers. So we're going to talk about experimentations, rollouts, and a lot of other interesting things related to A/B testing. But I also want to mention a couple of things that for time reason, we're not going to touch. Specifically, we're not going to cover all the data science part of A/B testing. So for example, how you do user allocation, how you do hashing. And also we're not going to touch anything about analytics. So how do you report back how your user is behaving and how you can track if your experiment is doing well or not. Those are pretty big topic and they probably deserve their own talk. So today we're going to just focus on remote configuration and values that can be remotely controlled. So if someone will ask me to describe our SDK and framework in a couple of words, I will use this code snippet. So what we want to offer to our developers is basically the possibility to do something like that. You want to be able to check if a certain value is enabled or not. For example, displaying real-time lyrics. And if it's enabled, you want to follow a certain path. And if it's not enabled, you want to follow the default experience. That sounds easy, right? Sadly, making these working right and also making sure that you can control that flag remotely is not that simple and actually is quite complex. So before we deep dive in the architecture of this system, I want to mention some of the principles that we followed for the development of our framework. The first one is the safety. So our main goal is to always deliver a consistent configuration. We want to make sure that our users are exposed to a certain user experience, and this user experience doesn't change while they're using the app. That would be really odd, and it will make impossible to make any sort of analysis from the experimentation and data science point of view. Also, we build the system to be fully fault tolerant. This means having capability to support offline scenarios and always have a fallback, that is the default value. We also try to build our system with developer safety inside. So using techniques like immutability, type safety, and so on, we wanted to make sure that our APIs are safe to use to make sure that we can prevent as much bug as possible. The second principle that we followed is ubiquity. The Spotify experience is not just on mobile. So we had to build SDK for Android, iOS, web, and C++. We actually deploy our experience to a lot of different platforms out there. So it's not just Android and iOS, but imagine like game consoles, autos, wearable devices, and so on. And so it's, as I said, it's not just the device, but it's also the form factor and the environment that changes. And even on a specific platform like on Android, we ship multiple apps. It's not just the music app. We have Spotify Kids, Spotify Lite, and so on. So we needed to build a system that could work on all of those environments. And the last principle we followed is simplicity. So our motto is our system should just work. The API should be simple to use, and the developer should not be exposed to the complexity of such framework. Specifically, we also try to use code generation as much as possible to avoid repetitive tasks for our developers. And we also offer a lot of tools to support developers in their daily work and to let them write, for example, tests or override values, to being able to try how the app should behave under different experiences. So now let me walk you through the high-level architecture of our system. So in order to understand, I need to introduce you three main actors that are part of our architecture. The first one is a software developer. The second one is a data scientist. And the third one is a user, a Spotify user. So each of those has different goals, and we're gonna walk through all of them. First, the developer will start declaring a properties.yaml file. So the developer will declare all the properties and the flag that they want to use. With that file, they can actually start building the logic for this new feature. Once they're done, their properties will be published within our infrastructure. So they will hit a backend service that collects all the properties that we will call remote configuration admin. Then it's up to the data scientist. Data scientist is responsible of setting up the experiment and the rollout. So they will use a tool called Backstage, that by the way is open source, and they will interact again with remote config admin to configure all the parameters. So which type of users should be exposed, which value the flag should have, and so on. Then a different perspective is the runtime. So when our users will get the new version of the Spotify app, they will go through the so-called resolve phase. So they will be responsible of getting those values, and they will be exposed to a certain experience. So they will interact with another service called remote config resolver that will interact with admin to compute a valid resolution for a certain user. So if the user is in South Korea rather than Italy, they will receive different values, and so on. So now we will walk through those 4 steps, and we will look them in detail. But first I want to start from the data scientist. So I mentioned Backstage, and I also mentioned before that I don't want to deep dive too much into the data science part of experimentation. So I just want to call out Backstage. You can find Backstage on GitHub, and there is also a demo site on backstage.io. You can try it out. We built a plugin for Backstage, so for our internal deployment of Backstage, that allows data scientists to interact with our system. If you're wondering what is Backstage, Backstage is a tool to create developer portals. So it's a web interface where all the tools that developers should use can be plugged in. So for example, CI, source code, tools like experimentations, and so on. If you don't know it, I really recommend you take a look. But now let's move over to the developer front. And the first step that we saw is the build. So the developer writing a new feature. And I mentioned that the first thing the developer will do will be to create a properties.yaml file. So let's see how these properties.yaml file actually look like. So as I said, it's a YAML file, and developers will just write in their properties. And every property should have an ID that should be composed from sort of like a package name, to call it like that, and the name. Like in this case, is the scope is player module, and the name is lyrics enabled. And for every property, the developer has to specify the type. For example, this is a Boolean property. And as I said before, we built fallback scenarios as a foundation for our framework. So in this case, and for every property, the developer has to specify the default value. In this case, the default value is false. But then we can have another property like this one. There is an enum property where we have like a list of values. And again, the developer has to specify which one should be the default. And also developers can use also the int types. So those are the three types that we support and are the only one. So Boolean, enum, and integer. And actually we noticed that developers can achieve a lot with these. We happen to have situations where developers come up with the request to have string types. But so far, we managed to achieve all the capabilities with the enum type. And that actually, not having a string type solves us a lot of problems. So let's look how the developer will actually build a new feature. So a developer will generally work in a certain module, like in a certain feature, in this case, the player module. So they create a properties, the YAML file, and we built a Gradle tool, a Gradle plugin that supports them when using remote configuration. So they will invoke a task that will be responsible of generating code for them. So this task will take the properties, the YAML file, and will start code generation. And so we will generate two things, a properties class and a Dagger module. The properties class is nothing more than a POJO. So it's basically an instance that will contain the value of this property. And the Dagger module is something to support the developer when injecting this instance in their dependency graph. So the output will look something like that, a player properties.java and a player properties module.java. Those files can then be used by the developer to code their business logic. So they can actually start writing the feature and have all the if then else to let the feature behave as they wish. As I said, we built developer safety as at the foundation of our system. So that player properties .java is a POJO and is fully immutable. So we try to make sure that once those classes are instantiated, they can't be changed. And they are type safe. So at compile time, a class will be compiled, will be created with the correct type, and there is no casting to do. So everything is really easy to use, and it's really hard for developers to do mistake on this front. We also, as I said, try to avoid string values because this could lead to scenarios, as I said before, that are like sort of hard to handle. For example, having special characters passed by inside a string or code being injected as like the value of a string property. So we just decided to don't have string values. Also, having these properties in the code base helps us achieve strong ownership. So now we know that the properties live within a certain module, and we know who is the owner of that module. So we can always go back to the team that is responsible of handling certain properties. This is thanks to Backstage. Again, take a look over there, but Backstage has the capability to register a source tree and to always tell you who is the owner of a certain file within a source tree. So now let's take a look at how the generated code will look like. So the developer will go inside their build.gradle file and they will just enable the remote configuration plugin. And then they will drop in the properties.yaml file, the file that we saw before. So I suppose that the developer already has a Dagger module for their feature called properties module. And then what they need to do is just to include this external module that we generated for them. Nothing more. Then in the logic, in the business logic, so I suppose there is a player presenter or a player view model or whatever logic they have, they need to inject the properties instance. So ideally they have they use field injection or constructor injection, and they just annotate the property with inject. Dagger here will do the magic and will make sure that there is an instance of this properties class for them available to use. So they can just wire this properties class in their logic. So they will have a show player, for example, function, and inside they can use the property and check if the lyric is enabled or not, and then update the code as they wish. We also do a little bit of beautification of the name. So for example, it was lyrics underscore enabled, and here we use like camel case instead, just to make the code looks better for our developers. So now let's go to the next step. There is the publish step. So the publish step is what happens next after the developer finished to code their feature and they're ready to merge, to master their new capabilities. So as I said, there is a player module with properties, a YAML file, but there are also a lot of other modules like search, podcast, playlist, and they might or they might not have properties, a YAML file. So there is another Grail task called publish properties, and this task is responsible of finding properties all around in the code base. And those properties needs to be published in our backend infrastructure, so in the remote config admin service. This step specifically happens on CI. So we want to make sure that properties are published on post-merge. So as soon as we merge, we also publish the properties. This is really convenient because we don't need to define properties twice. They will be defined only in one place in the code base, and you don't need to go to any web UI to like copy the string and make sure that the string in the web UI is the same in the code base. No, there is nothing like that. Properties are defined in the code base only. We can also run CI checks to validate. Those are YAML files, so we can read them and we can make sure that what you're about to publish is correct. And if there is something broken, you are not able to merge. Also, this helps us with strict versioning. So when you have a lot of properties, sometimes it's really complicated to know in which version of the app a certain flag was added and in which version it was removed. While in this case, given that the source code is our source of truth, we can always go back in time and find for a specific version of the app which properties were there in the source code. So again, what I already said, we strongly believe that having properties in the code helps us achieve having the code base and as the single source of truth. So properties are defined only once and only there. Specifically, our app is architectured in a way that there is an app layer, and then there is also a shared layer of C++ code between Android and iOS, and also there are properties. So again, this publish properties task is responsible also of finding properties both in the app layer and in the C++ layer. So the next step, and the different perspective here, is the resolve. I say different perspective because so far we were looking at build time and at merge time, while in this case, this is runtime. So this is what happens in the pocket of our users that are using the Spotify app. So again, there are a lot of modules with a lot of generated code. And then we have a client runtime SDK. So there is like a runtime library that is responsible of interacting with the remote config resolver service, getting a valid resolution for a certain user, and populating all of those properties classes as soon as they are instantiated. So when the developer requests to get a new instance of podcast properties, they will be populated with the correct value for that user. To fully understand this, it's also worth to talk a little bit about the fetch strategy that I'm going to walk you through in the next slide. But for this, we use the so-called activate and fetch. And we also do recurrent fetches in the background. It means that the app will keep on calling the remote config resolver every now and then, just to make sure that if there are changes for a certain user, they are refetched. So that if something has to change and the experience needs to be updated, we have a way to do it in a timely manner. So let's look at the fetch strategy. And this is like a high-level overview of how the app behaves. So the first thing that we do is the user opens the app and we ask ourselves, is the user logged in? Like, is this the first login for the user or not? If the user is not logged in, so they are actually seeing the login screen, we follow the fetch and activate. That's actually the opposite of what I said before, but because this is like a special scenario. So you're coming to the app and we don't know anything about you. So what do? We fetch immediately a configuration for you. So we try to check what are the values of those flags and we activate them immediately for you. This is the so-called first user session. If the user is already logged in, then we follow a different path. So we load the remote configuration SDK and then we check, do we have cached value for these users? Generally, yes. So if we do, we activate them because we loaded them in a previous session and so on. If we don't have them, then we activate the default configuration, the fallback scenarios that I spoke before. At this point, so you open the app, we loaded your cache configuration. It's also worth to make sure that these configurations gets updated from time to time. So we set up a so-called delayed fetch. So we go at a certain point in time to interact with remote config resolver. And this delayed fetch, again, is happening in the background every now and then to make sure that this configuration is as up to date as possible. So that's all. But before I go, I want to share with you a couple of lessons learned that me personally or us and as an organization, we learned when building this kind of software and those frameworks. So the first one is the correctness. As I said before, our goal is to always deliver a consistent configuration. We deeply believe that it's crucial to don't change the configuration at runtime. Specifically, we want to avoid scenarios like these where the user is seeing the UI and then a configuration gets reloaded and the layout changes at runtime. So this GIF is even more funny because the user misclicks the button. But generally, like if I expose you to a certain type of buttons, like if you're seeing red buttons and then in another screen you start seeing blue buttons, then you don't fully understand how your experience should be. So we really believe in delivering always a consistent configuration and do not expose users to multiple configurations at runtime. On this extent, I also suggest make sure that you cover every entry point. The app is not just starting when you click on the icon, but the app could be open for a variety of other reasons, like how about if user clicks on a deep link? How about if user clicks on a push notification? You need to make sure that if you need to load a configuration or you need to load like those flags values, they are loaded in every scenario correctly. And also it's crucial that you avoid situations like misbucketing. This means treating users in the way they should not be treated. Another learning is the difference between an experiment and a rollout. That's sort of crucial because at the end of the day, we talked about having values that can be remotely controlled. True, but they can be used for two different purposes. The first one is the experiment. With the experiment, basically you can evaluate the user behavior, you can collect insights, and the end goal is to make an informed decision. You want to understand if a certain color of a button is better than another, and so on. Rollouts instead are a different type of things. They can be used, for example, to test new libraries, or they can be used to gradually release a new feature, or they can even be used as a kill switches. If I'm if I'm rolling out a new version of a library, I'm not interested in knowing what's the user behavior. I'm more interested in knowing if the app is crashing or if there are performance changes. And generally, like, the rollout goes from 0 to 100% and then is considered completed, while an experiment, you will run it for like a couple of weeks, then you evaluate the result, and then you make an informed decision afterwards. So they all run on the same framework, but the analysis that you need to run for them are deeply different, and you need to make sure that your data scientists know what are the difference and the capabilities of the framework you're using. Another important point is the propagation time. So the first thing that happens to fully understand the propagation time is that the developer will just start building the feature and setting up the experiment. This generally takes like, I don't know, a couple of days. But then once their version is on master, they also need to publish a new version on the Play Store. That can take days, up to 7 days in our case. Then you go on the UI and you enable the experiment. So, for example, you change the value from false to true. But that value needs to be propagated to the user. Like, it's not that when you go there and you click from false to true that every user immediately will get that value. They need to open the app, they need to interact, and so on. So these all time can take from minutes to even days. Like, if a user are not using the app, they will not get the new value. These are all time. I like to call it propagation time, and it's the time between you coding the feature and users actually experiencing it. And it can take days or even weeks. So you need to be aware of what are the time capabilities also of the tools you're using. Another learning that I want to share is about life cycles, app life cycles and experiments. So you might use like those sort of remote configuration frameworks to run startup experiments. Like, maybe you want to control what happens up on create. And that time is really early in the app life cycle, and things might not be ready based on how you use dependency injection and so on. And you might end up in really weird scenario. So my suggestion in this front is pay attention on how your developers are using your properties and where they're placing them. It's also worth to have a capability to wipe faulty configurations. You might end up in a situations where you distribute a configuration to your users. That configuration is broken. Then the user opens the app crashes because it ends in a path where there is a crash. And it just keeps on crashing because the new configuration never gets reloaded. So ideally, something like a push mechanism could help, like to have a mechanism to wipe configurations to your users. And also could be useful to support, to speed up the propagation. Like, if you really want to push changes to users, you could, instead of waiting for them to fetch new configuration, you could actually push them using a push mechanism. And so, to wrap up, I also want to mention buy versus build. So at Spotify, we built our own tool, but there are actually a lot of other tools that will allow you to do something like that. There are solutions like Firebase Remote Config, rollout.io, or you could build something on top of Facebook Plan Out. You should think about the cost on both ways. Sometimes buying is more like cost efficient than actually building your own solution. And the speed. You have something that works out of the box. But if you build something on your end, you definitely have something that is more scalable to your experimentation needs and is more flexible. And also you can build safety directly inside your framework to achieve all the goals you want. And to wrap up, I also want to mention that in our case, building our own SDK with our own API allowed us to achieve developer happiness, because I mean, at the end of the day, my customer is another developer. So I'm creating API for them and I want to make sure they're happy with that and they enjoy using my tools. So that was our journey. Thank you very much for listening. Again, you can find me on Twitter and on GitHub on @Corti, and I'm more than happy to answer questions or follow-ups on any other form.